Hi, this is Srikanth, Assistant Professor of Triple Department. In this session, I am going to discuss the advantages and applications of different electrical machines. First, let us go with DC motors. Here, the DC motors are classified into different types based on their construction, characteristics, and applications. Each classification has its own advantage, and these advantages will contribute to the suitability of the motor for specific applications. Here are some of the advantages of different types of DC motors. Here the first one is permanent magnet DC motor. Here the permanent magnet DC motor, which is going to have a simple construction, because permanent magnets are going to provide us the field flux for the complete machine. So the construction is very simple because there is no field windings are present, because only magnets are going to be present. So the permanent magnets DC motors have relatively simple construction because there is no field winding, making them cost effective and easy to manufacture. It is easy to manufacture, and it is also a cost effective and high efficiency. Here PMDC motors are going to have a constant flux. Because of that constant flux, there is no losses in the windings because only magnets are present. So when there is no losses, which is going to provide a good efficiency, especially in small to medium sized applications, because permanent magnets are suitable for only small to medium sized applications. That's why. And here in these cases, we are going to get the maximum efficiency. And compact size. Due to the use of permanent magnets, these motors tend to be more compact and lightweight. And series DC motor. Here the series motor is going to have the field flux which is proportional to the armature current. So when the field flux is proportional to the armature current, the motors are going to have a torque which is proportional to flux into Ia, which is equals to torque is proportional to Ia square, because flux is also proportional to Ia. So when there is high starting torque, series wound DC motor provide high starting torque, making them suitable for applications requiring substantial initial torque. That is, DC motors are going to have high starting torques. So these motors can be used only where we are having the particular high amount of torque which is required, such as in electric vehicles and some industrial machinery. And it also used in variable speed. It is variable speed control. Series motors can be easily controlled for variable speeds by adjusting the applied voltage. And shunt motors. Here shunt motors are going to exhibit stable speed characteristics. Here shunt wound motors offer more stable speed characteristics than series motors, because the flux in the shunt motors is nearly constant, because we are going to provide the voltage which is in parallel to the shunt field winding. So when it is parallel, the voltage is constant. When the voltage is constant, automatically the flux is also constant. When the flux is constant, speed is proportional to flux, so speed is also constant. That's why these DC shunt motors are going to exhibit the stable speed characteristics than the series motors, making them suitable for applications where a constant speed is required, such as in certain industrial machinery. And compound motors, it is going to have combines characteristics. That is, these compound motor is nothing but which is going to have both series field winding and shunt field winding together. So these are going to provide the characteristics and features of both series and shunt motors. That is compound wound DC motor, which will combine the features of both series and shunt motors, which is providing a good balance between the starting torque and speed stability. And it is suitable for diverse applications. These motors are versatile and find applications in various industries such as manufacturing, automation, and traction system, because we are going to have both the operations, that is series and shunt. So series means high starting torque and shunt means which will maintain nearly constant speed. So the traction systems which requires high starting torque as well as speed maintenance. So that is possible with the compound DC motors. And brushed DC motors. Here brushed DC motors are relatively simple and cost effective due to the presence of brushes and a commutator for current reversal. Here, because of brushes, which is going to have the construction is simple and also cost effective. And here, because of these brushes, the control of brushed DC motor is straightforward, making them suitable for applications where simplicity is important. And the next one is brushless DC motors. The brushless DC motors are going to have longer life. That is, brushless DC motors have a longer lifespan compared to brushed DC motors, since they don't have brushes that wear out over time. And these are going to provide high efficiency, because BLDC motors often operate with high efficiency and are more energy efficient than brushed motors, and low maintenance. When there is no brushes, the maintenance is also less. The absence of brushes will reduces the maintenance requirements, making them suitable for applications where minimal maintenance is desirable. The next one is DC generators. The DC generators or dynamos are the devices which are going to convert mechanical energy into electrical energy, and these DC generators are classified based on various factors such as field winding connection, excitation method, and applications. Each classification comes with its own set of advantages and applications. Here are some general advantages and applications associated with DC generators classifications. The first one is separately excited DC generators. Here the advantages are independent field control. Here separate excitation, which allows for precise control of the field current, which resulting in better voltage regulation. And it is going to have high stability, Here the ability to adjust the field current independently, which enhances the stability of the generator. The applications, laboratory testing, separately excited DC generators are often used in laboratories for experimental purpose and testing due to their precise control capabilities. And critical applications where stable and well regulated voltage is required in certain industrial processes. And the next one is series DC generators. These series DC generators are going to have which are going to have the high starting torque, making them suitable for applications with variable and heavy loads. And series generators have simpler construction with fewer components. And applications, electric traction. The series generators are used in electric traction systems such as electric locomotives and electric vehicles, and cranes and hoist systems. And DC shunt generators. The shunt is nothing but which is going to have stable voltage characteristics because the flux is constant. So the shunt generators which are going to offer stable voltage characteristics, making them suitable for applications requiring constant voltage output and wide range of operating conditions where shunt generators can be operated for different load conditions with relatively constant terminal voltage. Here are some of the applications where we are having constant generators, constant voltage. So shunt generators generally used in power plants for stable power generation and general power distribution applications where a consistent voltage is essential, such as in general power distribution systems. In the compound DC generators, these compound DC generators are going to provide us the combined characteristics of DC series and shunt characteristics, which is going to provide a balance between high starting torque and stable voltage regulation. And it can be adapted to different applications by adjusting the series and shunt winding configurations. Applications, industrial machinery, compound generators are used in various industrial applications where a balance between torque and voltage regulation is crucial. Here the power stations, applications that require both high starting torque and stable voltage in power stations, we are going to use these compound generators. In the permanent magnet DC generators, here these are permanent magnet mode generators are simple and compact, and these are only suitable with low and medium level ratings, and it is going to have the low maintenance because there is no field winding. And these are used, PMDC motors are going to be used in small scale electronic devices, portable electronics and applications where compact and lightweight generator is required. The battery charging system, which is suitable for charging batteries in applications such as solar powered. The choice of DC generator type depends on specific requirements of the application, that is based on our voltage requirement, starting torque and their operating characteristics. Based on that, we have to choose the particular DC generator for our application. The advantages associated with each classification allow for the selection of generators tailored to different industrial, commercial and power generation needs. The next one is the alternators. Alternators are the devices or machines that converts mechanical energy into electrical energy in alternating quantity. There are mainly used various applications and they offer several advantages because whenever the AC power which is going to be generated, that will be transmitted and distributed over a particular area. So the mainly in alternator, the alternator's main application is it is used for AC power generation. AC power generation which is going to have compatibility with power grids where alternators are going to produce alternating current which is the standard for the power generation in most electrical grids worldwide. That is, alternators are the major devices which are going to produce the electrical power which is going to be connected with the electrical grids throughout the world. This makes them compatible with the existing infrastructures and allows for seamless integration into power systems. Stability of voltage and frequency. Here in the generators, the major advantage is which is going to provide a stable voltage output where because it is going to take a constant speed, that is synchronous speed, as the input, so which will provide us a constant voltage along with the frequency. Alternators generally provide a stable and well regulated voltage output which is important for the proper functioning of electrical devices and equipment because we need to maintain the voltage constant and frequency constant because we need to take care of all the electrical equipment. So frequency control, the frequency of the AC output from alternators can be controlled, making it suitable for applications that require specific frequency standards and high efficiency and scalability. Here the alternators are going to have a very good efficiency because the efficiency is crucial for optimizing energy usage and reducing waste because alternators does not have any commutators, so which when there is no commutator, the losses in the commutator and brushes are going to be reduced. So when the losses are reduced, automatically the efficiency of the machine is going to increase. And scalability, here the varied power ratings. The alternators are available in a wide range of power ratings from small units for portable generators to large units for industrial and utility scale applications. This scalability makes them versatile for different power generation needs. And easy of synchronization. Here, whenever we are having alternators, we can go with multiple alternators which can be connected in parallel to increase the total output power. Whenever we want to have a good maximum power than the rating of the alternator which is available, Then we can connect another alternator in parallel in order to increase the total output power, that is based on our demand requirements. We can have the number of alternators can be connected in parallel. That is nothing but a synchronization, and this synchronization controls ensure that the outputs are phased correctly. We need to maintain the outputs are going to be phased. That is nothing but whatever the RYB phase sequence with 120 degrees phase displacement, that should be maintained perfectly, which enables the efficient power sharing and load distribution. And reliability and durability. Robust construction. The alternators are often built with durable materials, and their construction is designed to withstand rigors of continuous operation. This results in reliable performance and longevity, which is going to have uh, the alternators are no need to have the regular maintenance, that is only like DC generators. There is no need to maintain the commutator, so the construction is very simple and rigorous. So when the construction is very simple, which can have the more reliability or more lifetime, which is going to provide us. And flexibility in fuel sources. The alternator can be designed to operate with various fuel sources, including diesel, natural gas, gasoline, and more. Any engine you can connect it to the alternator, which is going to provide us the AC supply, because engine is going to take the fuel and which will provide the mechanical energy. When the mechanical energy is given to the alternator, which will convert into alternating electrical energy. And this flexibility allows for adaptation to different energy availability and cost considerations. The maintenance and serviceability. The alternators are going to have typically fewer moving parts than some other power generation devices. When the less moving parts are there, which will lead to a less maintenance and service requirements and easy of repair. When maintenance is required also, many alternator components are easily accessible and can be replaced or repaired, which will reduces the downtime. And suitability for remote power generation. Here, these alternators are portables. These alternators can be incorporated into portable generators, which can be provided a convenient and mobile power source for remote applications or emergency situation. Like whenever we want to generate a supply for a period of 2 hours with we are having some diesel engine, then the diesel engine is going to provide us the mechanical output. That mechanical output is going to be connected to the alternators, which will generate the AC supply. The applications of alternator. The alternators find widespread applications in various industries and sectors due to their ability to convert mechanical energy into electrical energy. Here are some of the applications of alternators. The main application is power generation. The alternators are the fundamental components in power plant where they convert mechanical energy, often which we are going to get from steam turbine or water turbine into electrical energy, and that is connected to the electrical grid. And automotive charging stations, alternators are used to charge battery and power the electrical systems. They are crucial for maintaining electrical charge in electrical vehicles battery while the engine is running. In automobiles, this electrical charging is going to be done when the engine is running. These alternators are going to be the charging point for the batteries. And emergency power backup, alternators are going to be a key component or standby generators which will provide the backup power during the outages. When the power outage is there, then the generators are going to provide us as the backup power, such as wherever there is any emergency conditions or critical facilities such as hospitals and data centers and emergency response centers. And these are portable generators, mobile generators. Some generators can be used as portable generators which can be used as on the go power for construction sites, outdoor events and remote locations where a stable power source may be lacking. Wherever we require a continuous supply, then we are going to use these portable generators which will provide us the AC supply in any location, that is, which can be used for any location. And aircraft power generation, alternators are utilized in aircraft to generate electrical power for avionics, lighting and other onboard systems. They may be driven by aircraft's engine or auxiliary power unit. The marine applications, here the alternators are used in marine vessels to generate electricity for lighting, navigation equipment, communication systems and other electrical loads. They can be driven by the main engine or auxiliary engines on ships. And wind turbine generators, here alternators are employed in wind turbines in order to convert rotational energy from the wind into electrical power. This will play a crucial role in harnessing renewable energy for electrical generation. And as we have already discussed, the alternators are used in hydroelectric power plants and thermal plants where water turbines drive the alternators in order to generate electricity. The mechanical energy from the flowing water is converted into electrical energy. And industrial applications, alternators powers various industrial machinery and equipment including conveyor systems, pumps, fans and manufacturing process requiring electrical energy. The mining operations. The mining operations are used to provide power for equipment such as drills, conveyors and lighting systems. They are often integrated into mobile generators for mining sites. Mining sites are going to be for a kilometer's range, so we cannot have the normal generators. So mobile generators we can use, that is portable generators we can use for mining sites. And research laboratories, in scientific and research settings, alternators may be used to generate stable and controlled AC output power for experiments and testing. and telecommunication towers. In order to provide power to the off-grid telecommunication towers, where we also use the alternators communicate in the remote locations where grid power is unavailable. And construction sites, portable generators with alternators are commonly used on construction sites to provide temporary power for tools, lighting, and other electrical needs. The versatility of alternators make them indispensable in a wide range of applications where reliable and efficient electrical power generation is essential. These are the several advantages and applications of various electrical machines. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.